Hi everyone. So today we are going to do another LeetCode problem, that is two sum. This is a very famous problem in a lots of DSA interviews. So today we are going to solve that, and we are going to use the three-step method. So first step in this method is obviously to read the whole question with example. Okay, so let's just do that. Given an array of integer nums and an integer target, return the indices of two numbers such that they add up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So first example is array we have is 2, 7, 11, 15, and target is 9. The elements that satisfy this is 2 plus 7, that gives you 9, and indices for them is 0 and 1. Similarly, we have target 6 and arrays 3, 2, 4. I can see that 2 plus 4 is equals to 6. Indices would be 1 and 2. And same thing is implemented here. 3 plus 3 is equals to 6, and indices is 0 and 1. There is one follow-up question as well. Can you come up with an algorithm that is less than of n square time complexity? Okay, so let's just go to the next step, that is to think of 3 test cases other than the one provided in the question. So I have already written few of the test cases. Let's check the answers for these. So we have already, let's do this, that returns an empty array. Okay, answer is 0 and 1 for this question. Answer is 0 and 1. Then for the second one we have answer 2 and 4. Okay, here we have to write the target as 100. Okay, let's just, I think I've written some other array than the one here. Okay, target is different. Okay, so answer for this would be 2 and 4, right? 2 and 4. Answer for this would be 1 and 3. I think. Okay, one of the test cases giving some issue, so let's just omit that. 1 and 3. Okay, let's move on to the step 3, that is write down your thought process while you find the solution to these test cases. What does that mean is that let's say I know the answer and I know the question, so when I will try to find the answer myself, like how is this the answer, I'll write down each and every step that I do on the way. Like I have to write notes of my thought process. That's what I essentially mean with that. Okay, notes. So in the first test case, let's say we have 2, 4, 5, 6, 7, and we want to have a combination of two numbers that adds up to 6. So what I will do is I am going through the array once, and I'm trying to find a pair that matches this that adds up to 6. So I found 2 and then I found 4. That means I'm trying to find two numbers, and I'm iterating over the array to find two numbers. then what I'm doing is I'm checking whether they add up to, checking if they satisfy the condition, that is sum equals 6, right? Sum equals 6 or sum equals to k. Okay, so that's essentially what we are doing, and I'm returning the indices of the numbers that satisfy condition. That's essentially what I'm doing. So now if I try to create code out of this, is what I can write is this equals to iteration or loop. Since we are trying to find two numbers, there would be two loops. Then here this means is we are checking whether they add up to k or not. That means if condition for sum, and then this is a return condition, return if found, right? That's essentially what we are trying to do here. Let's code that up. So I'm doing it in Java, but you can definitely reproduce this code in any other language of your choice. So we have one loop, we have two loop. Okay, we have first loop and we have second loop. One thing here, that you may assume that each input would have exactly one solution and you may not use the same element twice. So there is no point on looping on the things that we have already tested for. That means we can safely say that we have to start from I plus 1. That is, if I'm searching for, let's say here, so I have already checked all the combination of 2 with each and every element, so we don't need to do that again. And since we can't use an element twice, so there's no point on iterating the j from ith position, otherwise it will give us a wrong number. So for example, in this case, like first iteration starts from here, and if second iteration also starts from here, it will give 0 and 0, which is not correct. So I and j needs to be unique. That's why we are incrementing j by 1, so I and j are never equal. So let's write down the condition that we have. If number at ith position plus number at jth position equals to k, this is the condition that we are checking. If their sum is equals to k, then we return those numbers, right? That's the second step. Now third step is return the indices of number that satisfy the condition. Okay, so here what we need to do is return an array with two indices, one is I and j. You can give it in any order, but I'm doing it like that, and we can return an empty array. Let's run this. Okay, so all the test cases are passed. Let's submit that. Okay, so obviously the time complexity for this would be big of n square, because we are having two loops. T of n square. Okay, since we have two loops, right? So as the follow-up question states, that you have to come up with an algorithm that is less than of n square, the time complexity. So since we are doing two loops, maybe we can find a way that we can keep a track of the numbers that we have already visited, and for that we need to keep a track of all the elements that we have gone so far and store the indices of those elements, and that will reduce one loop for us. So I can think of implementing a hash map here, which can save the elements that we have visited and indices for them. So we could have used set as well, but we need to keep a track of element with their indices so that we don't have to run another loop. So that's the thought process behind using a hash map here. Let's implement that version. Let's say we have a hash map and it contains integer and integer. Let's name it a map. So what we need to do is, we don't need this loop here now. We still need if condition that whether it satisfies or not, and we do need return, and if not, then we have to put the element inside the hash map. So what we are putting is I and index for that, so that we have a mapping for it. Let's say we are iterating over it, and what we are essentially trying to do is, let's say I iterate over 2, so I have a map and here we have stored 2 with index 0. Then we go to 4 and we store it 1, but before storing we check whether 4 plus some element gives us 6. So what we are essentially checking is whether 6 minus 4 is present in our hash map or not. That is, if this condition satisfies, we just return that. If I hope that makes sense. So we have to revamp this if condition. So let's say what we are trying to do is, we are checking if the element that we currently have plus any other element that we have visited already and is present in the hash map gives us the same result as k. So for finding that element, what we can do is a plus b equals to c. Then we can do search for a is equals to b minus c, c minus b. So we are going to subtract that from cth or kth element. So we are get k minus nums dot I, right? And if it's present, then we can have map dot get k minus nums dot I and I. Okay. What is the issue here? To a boolean. Okay, so it should be equals to map dot have contains key. Okay, contains key is a function that we are looking for, that returns whether we have that element existing in the map or not. So Yeah, that went well. uh, Time complexity is now reduced to of n, since map does not uh, requires any looping to search for. So that's a solution for this. I hope you are able to understand. Thank you.